Hello friends, welcome you all. In last lecture, we have discussed the soundness test, then compressive strain test of cement, then the storage of cement, precautions while uh, precautions while storing the cement on site, then the cement effect of storage of cement on the strength of cement. So now in this lecture, we are going to discuss the adulteration of cement. So what is the adulteration of cement? The change in the engineering properties of cement due to addition of impurities. What are the impurities? Impurities like stone dust, then fine sand, grit particles, broken bricks powder, or surki or lime. So we can call as adulteration of cement, or the process by which cement is made impure or inferior by the addition of these improper substances like these stone dust, lime, silt, clay, or fine sand, grit particles. They are called as adulteration of cement. So the chances of adulterate cement being received at the site cannot be ruled out completely. Okay. So if there any doubt, the manufacturer must be contacted. It is difficult to determine the extent of adulteration of cement at site. So the assistant of a reputed laboratory can be sought if it is in doubt. However, the simple test exists to determine whether the cement is adulterated or not. Okay. So there are many ways in which adulteration of cement can be done. So by mixing fine or powder fly ash, or by mixing fine silt or very fine stone dust from quarries, then mixing lime powder or old cement which has lost its strength may be adulterated in the cement. So here we can see the adulteration may be seen, visible lumps may be seen on the cement bag, in cement bags. Okay. So how we can determine this adulteration of cement? So some field tests we are conducted on cement to find out the adulteration, which is similar to the field test we are discussed earlier for field test of in section of field test of cement. So first, the color of cement should be greenish gray. If it is greenish gray, then we can call as it is unadulterated cement. Okay. Next is the cement should not have any visible lumps in it. Okay. So if there is a visible lumps, so we can say the cement may be adulteration may be done in this cement. Okay. Next is the unadulterated cement gives a cool feeling when hand is insert or put into the bag, and if it is adulterated one, then if we are putting the hand into the cement bag, it gives the warm feeling. Next is the pure cement should give the smooth feeling when pinch of cement is rubbed in a finger. Okay, if we are taking the cement in the fingers and if we are rubbing it, it should be give the smooth feeling. If it gives the gritty feeling, it means the adulteration of maybe a fine sand or the silt content is there. Next is the a handful cement should be float on the water before it dipping or sinking. That is, we are taking the handful of cement, and if throw on the surface of water, it should be float for some time and then it sinks. Next is the sharp edge should be remain unchanged even after 24 hours underwater. That is, we have to prepare the cement paste cake, sharp edge cement paste cake, and we have to put into the under the water for 24 hours, and after the 24 hours its shape or its edges should not be changed. Okay, so it is unchanged. Next is the color of the fresh cement should not be changed even after the burning. Okay, if we are burn the cement, it should not change its color. So these are the some field tests we are conducted to find out the adulteration of cement. Next is the importance of examining the adulteration of cement. Why the adulteration examination of adulteration is required? Let us see. First, the cement adulteration is very important to examine because or before its use, because impurity changes the properties of cement, and which is directly proportional to your the strength of cement. So next is the fineness of cement increases as coarser impurity particles get added in it. Okay, so the adulteration cement in the form of lumps may not mix properly, and which results in the increase in the standard consistency of cement. Means the percentage of water required for standard consistency of cement get increased. Next is the adulteration increases setting time of the cement, that is the initial setting time and final setting time of cement, which results in your removal of form work may be delay. Okay, and the construction work also delay. Okay, if the setting if the your concrete or cement is not set properly, so you cannot remove the form work early. Okay, so there may be the delay in the construction work also. Next is the impure adulterated cement shows more expansion under the temperature, that is unsound in nature. Okay, means the soundness test, okay, which are conducted on cement, the soundness we know should not be greater than 10 for ordinary Portland cement. And there is the if there is the unsound cement, it means in it the excessive lime is present. Okay, next is the compressive strength of adulterated cement reduces drastically because the lesser heat of hydration and bonding due to the impurities in it. Means heat of hydration and bonding due to the impurities of adulterated cement is less, and so the compressive strength of cement reduce drastically. So next is the types of cement. So let us see what are the types of cement. First is ordinary Portland cement. Next one is the rapid hardening cement. Next is the low heat cement, then Portland pozzolana cement, then sulfate resisting cement, then blast furnace slag cement, and lastly white cement. Okay, these are the general use types of cement. Okay, if we are changing the box compound or the percentage of box compound in the ordinary Portland cement, then also we get the different types of cements. Okay, so first is the ordinary Portland cement. So ordinary Portland, this type of cement is also called as normal cement, since its setting is normal when mixed with water. Okay, so it is general purpose cement used for construction work. Okay, which not required any special consideration. Okay, we are referring the IS code for this IS 269 1967 and 1975. Okay, so what are the properties of this cement? Let us see. First, fineness. The residue of this ordinary Portland cement does not exceed 10%. Okay, 10%. We know the fineness of the cement should not be greater than 10% for ordinary Portland cement. When it is sieved through the IS sieve number 9, that is 90 micron IS sieve. Okay. Next is the soundness of cement, that is the expansion of this cement should not be greater than 10 Okay. Next is the setting time. Initial setting time for this ordinary Portland cement should not be less than 30 minutes, and final setting time should not be more than 10 hours, that is 600 minutes. Then the compressive strength. Compressive strength for after 3 days test should not be less than the 115 kg per centimeter square, and after 7 days it should not be less than 175 kg per centimeter square when ordinary sand we are using. Okay, if we are using the standard sand, then its 3 days strength after 3 days strength test is 160 kg per centimeter square, and 7 days test is should not be less than the 220 kg per centimeter square respectively. Okay, so what are the uses or application of this ordinary Portland cement? So we are using this cement in PCC and RCC construction work, then plastering and waterproofing or painting works, Then the drainage works or water supply works, we are using the ordinary Portland cement. Okay. So next is the rapid hardening cement. So what is rapid hardening cement? This type of Portland cement is manufactured in that of similar way as the ordinary Portland cement, but it differs in the respect of chemical composition, that is degree of burning and grinding when the manufacturing of cement is done. Okay, in this cement, higher content of tricalcium silicate, that is C3S, percentage of C3S is higher in this cement. Okay, and finer grinding enables it to attain the greater strength at early stages. This is why this cement is also called as a high early strength Portland cement. This can be judged from the fact that the strength developed in these cases at the age of 3 days is approximately the same as that of the after 7 days in case of ordinary Portland cement. Okay, that is with the same water cement ratio. The high strength at early stages is due to what? Due to finer grinding or burning at high temperature and increase the lime content in the composition. So it should satisfy the all requirement as per the IS, and we are using the IS for this cement is IS 8041-1976. Okay, so when this cement is used, the formwork can be removed much earlier, and one set of formwork can be used for many more times. So this cement, hence the speed of construction can be also increased, and it is lighter than the ordinary Portland cement. So the curing period is short, hence this is the economical in construction. Okay, so let us see what are the properties of this cement. First, fineness. Fineness of rapid hardening cement should not be greater than 5%. Okay, that is when it is sieved through the ISU number 9. Okay, that is 90 micron ISU. So the residue on this 90 micron ISU should not be greater than 5% of total weight of cement. The specific area, if we are calculating using the Blaine's air permeability apparatus, the specific surface area of this cement is generally 3250 centimeter square per gram. Okay, next is the soundness. The its expansion is not more than 10 mm. Okay, for unaerated cement and 5 mm for the aerated cement. The setting time of this cement should not be less than 30 minutes, and final setting time should not be more than 10 hours, that is 600 minutes. Compressive strain. Compressive strength 1 day's test is should not be less than 115 kg per centimeter square, and 3 days it should not be less than 210 kg per centimeter square when ordinary sand is used. If we are using the standard sand, then for 1 day it should not be less than 160 kg centimeter square, and after 3 days it should not be less than 275 kg per centimeter square. So here we can see the difference. The 1 day strength is 115 kg per centimeter square, whereas the ordinary Portland cement strength is after 3 days is 115 kg per centimeter square. So it gives the much early strength. Okay, so where we are using this rapid hardening cement for road construction, where delay in traffic is not required. Okay, we know it hard rapidly, so the road construction work is also fast. Okay, so delay in traffic is not required. Second one is the Trima method of concreting in underwater construction work. Okay, this is the underwater construction method, that is Trima method. We are using the rapid hardening cement because yeah, the setting time of or it is hard rapidly underwater. Next is the manufacturing of concrete product like fencing pole, electric poles, doors and windows frame. We are using the rapid hardening cement, and lastly we are using it for the cold weather concreting. Okay, so hope you will understand today's session. Thank you.